All right, we close out the course with a narrower and more empirically structured apparent tension between evolution and ethics. For a long time, it was thought that evolution couldn't build altruistic creatures. Why? Well, because altruism means doing something that harms you or at least has a risk of harming you in order to benefit others. And it's hard to see, at least at first blush, how evolution could select for traits like that because anything harmful enough to you would tend to get selected out. You wouldn't produce as many offspring, and so such traits couldn't make it through the process of natural selection. Now, this is-ought gap, the naturalistic fallacy that DeWitt discusses, can be crossed in a whole bunch of ways, at least in principle, because if we can't behave altruistically, and many people seem to think that. Many people seem to think everything is selfish behavior in disguise. This is a wildly implausible view. Somebody who throws himself on a grenade may have some selfish reason to do it. He might want to escape feelings of guilt. But it's one thing to say every action has some connection to self-interest, and quite another to say every action is exclusively explained or caused by self-interest. Someone who throws himself on a grenade does it in part, at least, because he cares about his comrades in arms and doesn't want them to be harmed, and that's not self-interest in any obvious sense. But if we were incapable of behaving altruistically, then it wouldn't be the case that we ought to do so. We can't be obliged to do things we're incapable of doing. If one of you were to throw me off the top of the library here on CSU's campus and I were about to land on somebody's neck and kill them, it would be inappropriate of you to lecture me while I'm in the air saying, Casser, don't go around killing people. Because at that point, I'm just a projectile, right? So it can't be the case that we ought to do things we're incapable of. So it matters a lot whether evolution can build creatures that are capable of acting altruistically, and it's pretty plausible that they can. Some of the first passes involve the notion of inclusive fitness or kin selection. This is largely done from the standpoint of genes, not organisms. It can make sense for someone or some creature to benefit its kin. When you do the evolutionary modeling, those genes can make it into the population more readily than the genes of creatures that are self-interested at the level of the organism. We won't get into the complicated modeling, but you can see how evolution would select for creatures that look after their sufficiently close relatives. DeWitt neglects the units of selection problem, and it doesn't make it clear when he's talking about the self-interest of the gene versus the self-interest of the organism. And then there's the self-interest of a group or population. Those are separate issues, but it's pretty uncontroversial that evolution could select for creatures that behave altruistically towards sufficiently close relatives. It's also pretty clear that evolution can select for groups that exhibit reciprocal altruism among their members. If I expect you to have my back, it can make sense for me to try to have your back. This is where we get into things like the prisoner's dilemma. This matters a lot to creatures like us who have had to cooperate. Now, look at page 311 in your DeWitt book when you get a chance. Don't necessarily put down this lecture in order to do so. He's got an accurate rendition of the prisoner's dilemma, but it's a little bit misleading from the standpoint of the classic prisoner's dilemma. He presents it in terms of benefits, whereas classically it's in terms of harms. So let's take a break and think through that as the classical prisoner's dilemma unfolds. You and I have committed a crime together. We're being interrogated in separate rooms. Each of us has the choice either to confess or to stay quiet. If we both stay quiet, they can't pin the crime on us and we'll go free. If we both confess, we'll get a modest sentence of, let's say, 5 years. If I confess and you stay quiet, I'll get 1 year and you'll get 10. If you confess and I stay quiet, I'll get 10 years and you get 1. So if you plug that into the prisoner's dilemma matrix, you'll see that no matter what you do, it's in my interest to confess. And no matter what I do, it's in your interest to confess. Right? Because if you stay quiet and I confess, I get the better alternative for me. If you confess and I confess, I get the better alternative for me. So if we each do what is better for each of us, we both get a 5-year sentence rather than say a 1-year sentence or getting away. So what is good for each of us isn't good for both of us. So a prisoner's dilemma is the classic version of what's called an each-we dilemma. If we each do what's rational for each of us, we are worse off than if we could find a way to cooperate. Part of the problem of a prisoner's dilemma is you're isolated, you're being interrogated in different rooms, and there's no way to cooperate. But if you iterate this prisoner's dilemma setup, not the exact prisoner's dilemma, then you can show that cooperation is a rational strategy. Robert Axelrod's tournament, this was a big deal when I was in graduate school at Michigan. Axelrod teaches there. These are important results. Show you in decision theoretic or computer programming terms the value of nice programs. Nice is a very specific notion here. Don't be the first not to cooperate. They overwhelmingly outperform not nice programs in self-interested terms in the long run. This is a pretty robust result. It's dangerous to be too nice. You need to find some role for retaliating and punishing, but also for forgiveness. That comes out in the discussion of the ultimatum game. In terms of the final exam, I'm going to hold you responsible for the Axelrod stuff, for the prisoner's dilemma stuff, understanding how that works. Other things, the ultimatum game and the trust game, by all means work those into your essays if you'd like, but really they are supplements to this basic moral that you can be evolutionarily successful. Winning the prisoner's dilemma game is supposed to be unpacked in evolutionarily self-interested terms. It's thriving in some sense. So nice creatures, as defined in this sense by Axelrod, tend to do better than mean creatures. This is not shocking, right? Even if you just want to lead a happy life, if you're basically a selfish person, you'd better be willing to form attachments to your friends and to treat them decently. Otherwise, you won't have any friends and your life won't go well. So this is not shocking, but to have it demonstrated in this way makes a lot of sense, and there's a lot of wisdom that you can apply to your life. In most of these cases, punishment requires altruism. I can only discourage selfish behavior by sacrificing something myself. Right? In the ultimatum game, I have to turn down the money you've offered me, and so I get nothing in order to keep you from getting something if you offer me too little money. And it turns out, in fact, most people are willing to behave somewhat altruistically. There's a hard core of about 25% who tend not to. Interestingly, the evidence seems to be cross-cultural and across social classes and things like that. So humans are not, in general, at bottom selfish creatures, and evolution would not have to build at bottom selfish creatures. This is, of course, pretty simple version of it for a 100 level class. So we are pretty good at handling each we dilemmas of the sort that reflect the conditions under which we evolved. Relatively small groups where you get a reputation, where people know about you. If people know you, then you don't want to be an asshole, because that'll get around and your life won't go well. It's under conditions of anonymity and in large groups, like the internet, does not bring out the best in people. Environmental issues like the tragedy of the commons, right, having to conserve water or not pollute. Those are large-scale issues where you don't acquire a reputation and you don't have the same self-interested reasons for behaving altruistically. And so our abilities to feel trust and empathy and responsibility and to care about our reputations arguably are tied to the conditions under which we evolved, with small groups, where if you couldn't trust somebody, you would eventually figure that out. Lots of repetition because you're in it together. This makes us susceptible to the moral dilemmas that are plaguing us. Things like climate change, we do not seem to be evolutionarily well equipped to handle. Things like racism seem in part to be an inheritance from having evolved in small groups where there were insiders and there were outsiders, and you couldn't trust people who were outsiders. So, evolutionary biology can cast a lot of light on the most pressing problems we face. Science in general can cast an awful lot of light on the most pressing problems we face. DeWitt, I think, sometimes suggests that science explains away those problems, whereas I would suggest more modestly that it provides essential information for confronting those problems. Whether this class has gone well or badly for you is largely a matter of how much thinking about these issues you do after the final exam and whether your thinking has been improved by those matters. Good luck with that. Feel free to contact me after the course is over if I can be of any help in your intellectual endeavors. Thanks for hanging in there. Bye.